Welcome to this complete guide on reduction formulas and integration. Let's learn how to tackle powers of trigonometric functions step by step. What is a reduction formula? A reduction formula expresses an integral of higher power in terms of a lower power. For example, the integral of sine to the n reduces to sine to the n minus 2. The benefits are: it solves integrals that are hard by other methods, it provides a systematic approach you can repeat until done, and it works for sine, cosine, secant, and tangent powers. Let's derive the sine reduction formula. Start with the integral of sine to the n of x. Write sine to the n as sine to the n minus 1 times sine. Then integrate by parts. Let u equal sine to the n minus 1 and dv equal sine dx. After working through the algebra, we get the formula. The integral of sine to the n equals minus sine to the n minus 1 times cosine over n, plus n minus 1 over n times the integral of sine to the n minus 2. Let's apply the formula to integral of sine to the 4. With n equals 4, we get minus sine cubed times cosine over 4, plus 3/4 times the integral of sine squared. Now apply the formula again with n equals 2. Sine squared integrates to minus sine cosine over 2 plus 1/2 x. Combine everything. The answer is minus sine cubed cosine over 4, minus sine cosine over 8, plus x over 8, plus c. Now the cosine reduction formula. The technique is identical. Integrate by parts. The formula is integral of cosine to the n equals cosine to the n minus 1 times sine over n, plus n minus 1 over n times the integral of cosine to the n minus 2. Notice the positive sign instead of negative. The sine formula has minus sine to the n minus 1 cosine over n, while the cosine formula has plus cosine to the n minus 1 sine over n. Let's try integral of cosine to the 5. With n equals 5, cosine to the 4 times sine over 5, plus 4/5 times integral of cosine cubed. Now n equals 3, cosine squared times sine over 3, plus 2/3 times integral of cosine. And cosine integrates to sine. Putting it all together, cosine to the 4 sine over 5, plus 4 cosine squared sine over 15, plus 8 sine over 15, plus c. The secant reduction formula uses the identity secant squared equals 1 plus tangent squared. The formula is integral of secant to the n equals secant to the n minus 2 times tangent over n minus 1, plus n minus 2 over n minus 1 times the integral of secant to the n minus 2. This is valid for n greater than or equal to 2, where n is not equal to 1. Applying to integral of secant to the 4. With n equals 4, secant squared times tangent over 3, plus 2/3 times integral of secant squared. The integral of secant squared is simply tangent. So the final answer is secant squared tangent over 3, plus 2 tangent over 3, plus c. Let's summarize all three formulas. For sine to the n, minus sine to the n minus 1 cosine over n, plus n minus 1 over n times the lower integral. For cosine to the n, plus cosine to the n minus 1 sine over n, plus the same fraction times the lower integral. For secant to the n, secant to the n minus 2 tangent over n minus 1, plus n minus 2 over n minus 1 times the lower integral. Here's a practice problem. Evaluate the integral of sine to the 6. Use the sine reduction formula twice. Pause the video and try it yourself. The answer is minus sine to the 5 cosine over 6, minus 5 sine cubed cosine over 36, minus 5 sine cosine over 24, plus 5x over 16, plus c. Great job! You now understand reduction formulas. Remember, reduction formulas lower the power of sine, cosine, and secant. They use integration by parts. Apply them repeatedly until the integral is simple. Always add c for indefinite integrals. Keep practicing.